Okay, here it is Friday. What we're going to do is just answer some questions on the worksheets you've been working on. I handed out 3 more worksheets today that just have to do with expressions so you can practice. So I think that's what we're going to do today. I'm going to not talk very long because I've got a really bad sore throat. So Rebecca, do you have one that I should start with?
DS1.
It'd be better if you just tell me what the problem is.
Oh, okay, it's x over 2 plus 3, and then the greater going to the right, 9.
Okay. Okay. This is one of those that does still give some of you trouble. So we know that we can solve this exactly the same way as we do regular equalities. So we're going to follow the same rules. We're going to put the line down through the sign. Now it's not necessarily an equal sign, but we're putting the line down through the sign, and we circle our variable. These are very valuable steps to do at the beginning. And then the circled variable is the one that we want by itself, so we focus on this side. In order to get this by itself, I have to get rid of the 2 and the 3. We found out that the 2 is so close to the x that it's a best friend. And so we're going to get rid of the 3. I call it the straggler. We're going to get rid of him first. Right now, the sign that goes with the 3 is to the left of the 3. The signs are always to the left of the number, not behind it, in front of it. So to get rid of the 3, it's a plus 3, and the opposite operation of plus is minus, and so we're going to minus 3. And in order to balance this, I've got to subtract 3 here also. And when I do, I'm drawing this line because we're going to finish with this stuff and have a brand new inequality to deal with, so you don't have to deal with all the extra stuff. It also takes me from step to step to step. So I found out here that a positive and a negative of the same number are called additive inverses, and they make a 0 pair. So that's gone. And all that I have left when I add straight down is x over 2. I didn't divide or multiply by a negative. Here's a negative, but it wasn't divide or multiply. So I don't change the inequality sign. I leave it the same, and 9 minus 3 is 6. Okay? Circle the variable again, so it tells us to continue to look at this side and get rid of everything that's with the x. So now I have to get rid of the 2, and the 2, how is the 2 connected to the x?
Divide.
It's connected with divide, so how do you undo divide? You multiply by 2, and since this is a fraction, I want to make this one a fraction. You can make any whole number a fraction by putting it over 1. If I multiply on this side by 2, I have to balance again, and I'm going to take this side times 2. The reason I don't put this over 1 is because I'm not dealing with a fraction. 2 over 1 and 2 are the same thing. So now let's go to our next step. We found out that a numerator and a denominator that match can be canceled and give us 1. So when I look at this, when I look at this multiplying fractions right here, the bottom is 1 times 1. Well, if we have a 1 on the denominator, we don't write it. It's invisible. And so on the top, I have 1 times x. So I have 1x over 1, but we don't write that. And actually, the 1x here is also invisible. So we have an x by itself, which is what we want, is greater than 12. Now this is the answer because the x is by itself. That's how I know I'm finished. But now we also decided that we know how to graph. So let's graph this inequality. Since there's only one variable, there's only going to be one line. When you have two variables, that's when you have the X and Y axis. But we only have one variable, so we don't need this. Okay? So we have 0, just because we need a place value, and then we find our important number, which is 12. And it's very important, so we're going to circle it. Now, we have two decisions to make. We have to decide whether we color this in. We do not color it in because it is not equal to. If there was an equal line here, then you would color it in. We don't color it in because it's not equal to 12. It's greater than 12, but not equal to 12. So we can't color that in. And then the second decision you have to make is which way that you're going to shade. And you're going to shade in the greater direction because X is greater than 12. So you go in the plus direction. This is the minus direction. It's greater than 12. Does that help, Rebecca?
Yes, ma'am, thank you.
Okay.
I have a problem that I couldn't solve.
All right. Let me erase this one.
I probably just need a little help.
Maybe just a little hump to get over.
Get started.
Yeah. And I don't mind at all. I think solving equations and inequalities is really a foundational thing that you need to learn for everything else. And I think I'm really pumped about how you guys are learning it. So we're going to do great on other stuff. All right, I'm ready.
Negative 6x plus 20 more than or equal to negative 11x.
When I circle the variables this time, they're spread out. And we can't have an X by itself if it's in all these places. So the very first thing we're going to take care of is to get rid of one of the X's. I think of this as a fence in two different yards, and these X's got spread out. They all need to be in the same place, okay? So that means that we have to get rid of one of them, and then that will end up back in the yard that it belongs in. So you can get rid of either one of them. You can add an 11x, or you can add a 6x, and that's okay. You would get the right answer. But if you get rid of the one that's by itself already, then all that will do is just add some steps to your problem. So you might as well get used to getting rid of this one, okay? Either one of them, again, will give you the correct answer. You'll just go through more steps to get there, okay? So let's get rid of this one. Now I want to explain again that when we've had a 6x or a negative 6x before, we have always divided to get rid of that negative 6. But when we divided, it only got rid of the negative 6. It didn't get rid of the x, right? So in this case, I want to get rid of the whole thing. So I don't look at the divide, I look at the minus, because I want to get rid of the whole thing. So since it's minus 6x, I'm going to add 6x. And balance, I'm going to add 6x over here. And now I have, this is 0 because it's positive and negative are the same thing. Additive inverse gives you a 0 pair. So I have 20 is greater than or equal to, and notice that the 11 is bigger. So when you subtract these, you get 5, but it's negative, and it's x's because what we're dealing with is x's here. We're subtracting x's. Okay, now when we get to this point, let's circle the x, and yay, we finally got everybody back where they belong. So now we can, solving for the x, I need to get rid of the negative 5, right? How's the negative 5 hooked to the x? multiplied. So
Divide.
you have to divide by exactly what you want to get rid of. So we're going to divide by a -5 because we were looking at this side. That's why we know we weren't dividing by 20. Okay? Some of you get on the wrong side. To balance this, I want to divide by a -5 again because I have to balance by putting exactly the same thing on both sides. When I do, two negatives in a fraction cancel each other out, making it positive. 5 divided by 5, any number divided by itself will give you 1. Don't put a 0 there. It's 1. So on this side, I have a 1x. And on this side, I have a -4. Okay? This is a good one, Naomi. But look, every time you're dealing with inequalities, you need to look at what happened in the step before. And we divided by a negative. You divided by a negative. If you divide or multiply by a negative, you have to switch the very next sign. And so when we get down here, I'm just going to get rid of that. When you get down here, because we divided by -5 in this step, the very next step I have to change the sign. And this is the answer. This is the answer. But when you graph it, sometimes it's easier if the x is over here, okay? But if you don't want to move the x, this is what you do. You read from the x. You say the words from the x. And so you say x, and yes, that's a less than sign, but since you're reading it backwards from the x, you say x, and here's a big thing. X is greater than or equal to -4, which is very confusing, right? But if you want to read it backwards and not do anything else, you'll say x, and since that's big, you'll say x is greater than or equal to -4. But that just goes against everything you know. And so the easiest way to convert this so that you can graph it is to take the whole thing like it was on a piece of paper and totally flip the whole thing over. It's not mathematical. It's just getting it in a better place so that you can graph, okay? Something that you're more used to. So when you think of this on a piece of paper and you're flipping the whole thing. So if you flip this whole thing, you're going to have x, and you're even doing this, and -4. Do y'all see? And the way I check it to make sure I flipped it correctly is in the answer, the x was with the big stuff. So I look here and the x is still with the big stuff. That's what I want. And on the correct answer, the little point was pointing to the -4. I want to make sure it's still pointing to the -4, which it is. Do you see? So be sure and check that you flipped it correctly. And now this one is easier for us to graph because the x is on the left-hand side. Now understand that when we divided by a negative, we did a mathematical flip the sign. Are you guys okay with that? But when we got the answer, we only turned the card over. Do you see? Okay, so this part wasn't mathematical. I want to make sure you understand that. So we're going to graph. Here's 0. Our important number is right here. And it's important, so we circle it. And then do we fill it in or not?
Yes.
Yes, because of the equal sign, we're going to fill this in because it says not only is x all the numbers greater, but it's equal. It's equal to -4, and this is the way we tell on a graph. And then if x is everything, every number bigger, greater than -4, which way do I shape?
Right.
To the right. Mm-hmm. You guys are good. Did that clear up the piece that you needed? Mm-hmm. Okay, good. Good.
On the graph, the picture on the graph here, of that problem,
Mm-hmm.
it doesn't have a 4 in there, so do we kind of like imagine where we think 4 is at on here? Because it's like
I want to
0,
see
8,
before I answer.
See,
Oh, you're supposed to be able to see if this is 8, then this has to be 4.
right, that's what I was saying.
Yes.
Just imagine.
Yes,
Make sure.
good. Any other stars?
Yes.
Okay, let me get this one over here. All righty.
Okay. It's 3 multiplied by the double of
Oh,
F.
okay, it's words.
Yes.
Okay,
Okay. Okay, so it's multiplied.
let me just write it out.
Okay.
All right, here we go. Three multiplied.
By the double.
This looks familiar.
What year you on?
It's the ES2.
And there's a lot of ES2s, so tell them what the title is.
Translating phrases, multiply step equations.
Multiple steps. Multiple steps equation ES2. Keep telling me and we'll tell them again.
Okay. Okay, so of F,
F like father.
yeah, minus 9, the equivalent,
I don't want to do this. Is equivalent.
yes, to 15.
This is the one that I said there's like 3 different ways you could write this thing. So you guys, hang on to your hats. Because the way that this is worded, you could do it several different ways. I think okay, I think the way that this is done on the paper, did y'all find it? Okay, I'll find that paper if you guys will make a note and I'll get you that paper. Okay, 3 multiplied by, so we know that we're going to multiply and we know this is 3, right? So we've got this. Double means 2 times. So if you don't have that in your vocabulary list, put that in there. Double. Double. Now, in the answer, I think I'm not going to tell you the other ways. Okay? I'm just going to tell you what they have in the answer. I hope this is it. 3 multiplied by the double of F. Okay? The double of F is 2F. The double of F. Double means times, 2 times. The double of F minus 9, okay, is equivalent. This is a new word for you. I think we've seen it once. But look, it looks just like equal, which is, that's what it means. Is equivalent to 15. So what do we have here? We have 3 times the double of F minus 9 is equivalent to 15. So look on the back on your answers and see if this is the way they're thinking.
It is.
Okay, good. Okay, this one is a little bit ambiguous. You could write it a lot of different ways, but I'm not going to mess with that. Okay, if we're going to solve this, now that page was just translating, wasn't it? But we need to always practice solving, okay? So here's the F, and we know we cannot go up inside of here and get anything. So the plus 9 is out of the question right now. We're going to focus on this side. And you know our PEMDAS says to do paragraph or parentheses first. Since we can't subtract because we don't know what F is, then we're going to do the distributive property because this guy out here is crammed up next to the parentheses, which means times. And he's the guy with the key. He can unlock this. So he's going to do the distributive property, which is 3 times 2. We've got 6F minus, and then 3 times 9 is 27 equals 15. Now it gets better. Because if you circle the F this time, we're focusing on this side, and it says we're going to have to get rid of the 6 and the minus 27. Which one goes first? Which one do we get rid of first?
27.
The 27. It's a minus 27, so we're going to plus 27, plus 27. This is a 0 pair. We've got 6F equals 42. Is F by itself yet? Then we can't stop. What do we need to get rid of now?
The 6.
The 6. How's it hooked? So you divide. Going to divide both sides by 6. Any number divided by itself is 1. So now we have F is equal to 7. And now that is the correct answer because F is by itself. Now I want to show you something. If they ask you to graph that, it's almost confusing because you're used to coloring in dots and shading and stuff, but this is not an inequality. So let's just make sure that you know that the graph of this equation is, we're going to do the same thing. 0 is a place setter and 7 is our important number. And it says F is equal to 7. That's the graph. If it's equal to it, just color in that dot. There is one later on. I want to show you this while we're on the subject. When they're having you graph inequalities, sometimes they stick in a problem that looks like this. And it says graph this. Okay, if you'll notice, right here, there's no fractions, there's no decimals or anything, there's only 5 points, right? So when we graph this, here's our 0, our place setter. All of these are important. So here's 2, here's 4, here's 0, here's -3, and here's 1. Okay, all of those are important. And because they're important, we're going to circle those. And if it says X equals these things, then you're going to color in only the dots. Now the reason for this, if we were to color this line in that connects them, then we would be saying that X also equals -2 here, and -1, and 2.5, and 1.73, we would be saying, when we color it, we say that X is equal to everything in between all these numbers. And this doesn't list anything with fractions or decimals. It says X is this, X is this, X is this, so on. So when you graph that, it's simply going to be just those numbers. Do y'all see? Okay. Questions? More?
It's Friday. Woo woo.
Yes, we can celebrate that. More stars. I will work whatever, and then
I got one more. with
you
stars
guys
that
can-
you told me, Mark.
all right.
It's gonna be the ratio
Mm-hmm.
of sum.
Okay, wait.
Okay. Of 15. And 7 times H.
H,
Yeah, H.
like hospital.
Yes.
Okay.
To 3 is 12.
This is a perfect time to talk again about ratios. Okay. A ratio we think of most of the time as a fraction. And right now, in what you're doing, the ratio is a fraction. Now, a ratio, let's say 3 to 4. We look at it as 3 divided by 4. We can also look at it as 3 to 4. So this is another one of those connections. When you see ratio, you know that they're going to give you the first one, and then they're going to give you the last one, and you're going to know when it's there because of the word to, okay? This is your key on a ratio. So you can think of it here, if it's a ratio, this is the 2 right here. 3 to 4. Ratio 3 to 4. Do you see? So immediately, when you see the word ratio, then let's look for the word 2. Okay? So now ratio tells us we're going to have a top and a bottom. Okay? And the 2 is when we switch to the bottom. Okay? So all of this stuff up here before we get to 2 goes on the top. Ratio of the sum. What do we know when we do sum? Parentheses and
adding.
add goes in between. The word sum, we have to have parentheses and the add sign because sum means addition. Now, the very next stuff will tell you what to put here, and it's separated by the word and. So the sum of 15 goes here, and
7 times.
7 times h, because we haven't gotten here yet, okay? So 7 times h is going to be 7h. Y'all see? Word problems, you just break them apart into little pieces. Now, when we get to the word 2 that goes with ratio, then we know we're switching to the bottom of the ratio, to 3. Is means equals, so we're going to move on over to equals 12. Do y'all see how ratio works? It'll usually say ratio and then you'll find the word to somewhere. I say usually, you know, sometimes they'll switch it up, but this is normal. Okay, so now let's solve it. Uh-oh. Those of you on the recording probably need to see the whole problem. Okay. All right, we're going to solve this. Line down through the equal sign, circle the variable, and we breathe a sigh of relief because there's only one H, so we don't have to do that step to get everybody together. So the next step is we're going to look at this side because that's where the H is. We're going to have to get rid of, let's see, let me make this. I almost forgot what this was. There we go. All right. We're going to have to get rid of the 3. We're going to have to get rid of the 15. We're going to have to get rid of the 7. But since this is in parentheses, we know we can't go up there and get the 7. We can't go up there and get the 15. So we're left with the 3. And the 3 is what we want to get rid of anyway, right? So we're going to focus on the 3. How is it hooked to the rest of the problem? Divide, so we multiply to get rid of it. Multiply by 3. Since we're dealing with a fraction, we put it over 1. This is on one side, so I have to immediately do it on the other side. I caution you not to do this until you put the 3 over here. It's too easy to forget to put it on the other side if you start the mathematics. So now we know that we have a numerator and a denominator that are the same, so we can cancel those and make them 1s. Now we just have 1 on the bottom. We don't deal with that anymore. On top, we have a parentheses with a number out front. This 1 is like the 1 here. So we're going to multiply here. This unlocks the door, plus 1 times this one. 7H equals 36. Okay? And circle the variable. And now what do we need to get rid of? Sorry, what do we need to get rid of now?
15.
15, and the sign is plus. So we're going to minus 15, and we have to balance on the other side. 0 pair. So we have 7H left equals 21. Circle the H. Divide by 7. When we do, 7 divided by 7 is 1. 21 divided by 7 is 3. So we have H equals 3. Let me answer. Getting better? Are you okay? I like to give you a hard time. I love the sign language in the back. Lots of sign language in the back. Okay. Okay, any more questions? Because I would like to give you the rest of the time to work. On Fridays, we know we get out early. And so, woohoo. So I want you to work on what you have. I'm going to get some copies for me, for Rachel. And if you find out you're missing a page, you know, when comparing it to other people, bring me that page so I can find it, because I know I have it in my files. I just have to see which one it is that you need. All righty? Okay. And Naomi, when I get done with all that, I'm thinking about challenging you.
Take your time.
So there's H3.
H is equal to 3.